This is a video on triple integrals. The question states, sketch the solid whose volume is given by the triple integral, and then change the order of integration to dx, dy, dz. And we have the integral from 0 to 1, from 0 to 2 minus 2x, from 0 to 4 minus 4x minus 2y, of dz, dy, dx. So let's first look at this triple integral and see that this inner limit, that's a dz limit, so that means z goes from 0 to 4 minus 4x minus 2y. So I can write that z equals 4 minus 4x minus 2y. And then we can rearrange the terms a bit and write this as 4x plus 2y plus z is equal to 4. And this is a plane, and I draw the plane. Notice that if y and z are 0, x is 1, so it goes through x equals 1 for the x-intercept. If x and z are 0, y equals 2, so it goes through y equals 2 for the y-intercept. And if x and y are 0, z equals 4, so it goes through z equals 4 for the z-intercept. So here's my plane. The little man is standing up because we have dz, dy, dx. Notice that this line here that crosses at x equals 1 and y equals 2 does have the equation y equals 2 minus 2x. And also, the little man, the very farthest on the x-axis, the man can get is 1, and it's also bounded by 0. So we are going from 0 to 1. So that means we do get this entire solid. We call it a tetrahedron. So now we want to switch the limits of integration so that we have dx, dy, dz. So that means we change the way the little man is standing. So I'm going to put the little man standing so his feet are on the yz plane because we have dx for our first limit of integration. So then the little man's head is still on the plane and the feet are at 0. But I want to solve for x, so I can divide by 4 and then move things over and get that x is equal to 1 minus a half y minus a fourth z. And that'll be the inner upper limit. So now I want to look at the little man and look at the little man on the shadow on the yz plane. So I put the little man standing here, so the feet are on the z-axis, and the head is on this line right here, and that is on the yz plane when x equals 0. So if I plug in 0 for x right here, then I can solve for y and get that y equals 2 minus a half z. So I divide it by 2 and then move that 1/2 z over. So that'll be the middle limit, that y will go from 0, because that's where the little man's feet are, to 2 minus a half z, because that's where the little man's head is. And then for the z limit, the very farthest down the little man gets is 0, and the farthest up the little man gets is 4. So the z limit will go from 0 to 4. So now we're ready to write down the triple integral with dx, dy, dz. And we get that z is going from 0 to 4. Y is going from 0 to 2 minus a half z, because the little man goes from 0 to 2 minus a half z. And then x goes from x equals 0 to x equals 1 minus a half y minus 1/4 z. Then I have dx, dy, dz. And I'm done with the problem.